Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Chemistry Paper 2 Higher Tier from 2024. Question number 5 is on the topic of the rate and extent of chemical reactions. Sulfuric acid is produced by an industrial process. In the process, sulfur dioxide, SO2, reacts with oxygen to produce sulfur trioxide, SO3. The equation for the reversible reaction is given over there. So that's your reversible reaction, and this sign indicates that this double-headed arrow indicates it's a reversible reaction. The forward reaction releases 198 kilojoule per mole of energy. Now, if it's releasing, then it's a exothermic reaction. The forward reaction is exothermic. What is the amount of energy transfer during the reverse reaction? Now, in a chemical reaction, if the forward reaction gives a certain amount of energy, then the amount of energy required for the reverse reaction is exactly the same. So it should be equal to 198 kilojoules per mole. 5.2. The concentration of oxygen is increased. What is the effect on the position of the equilibrium? So let's have a look at the equation again. If you increase the amount of oxygen, according to the equation, 2 moles of sulfur dioxide is reacting with 1 mole of oxygen to form 2 moles of sulfur trioxide. So if you increase the amount of oxygen, what it's going to do is going to try and reduce the number of moles of oxygen. So the forward reaction is going to take place. So the position of the equilibrium is going to move towards the right. Now, this is where most of the students make errors. Which side is the right and the left? This is the right side as you're seeing it. Right side, and this is the left side. So what is the effect on the position of the equilibrium? The position shifts through the left, that is the backward reaction. Now the position does not change. Now the position shifts to the right, which is the forward reaction. The pressure is decreased. What is the effect on the position of the equilibrium again? Again, remember the reactants ratio to products, because they're all gases. It was 3 moles, 2 moles of sulfur dioxide and 1 mole of oxygen. The reactant, total number of moles of reactant is 3, and the number of moles of product was 2. So if you reduce it, it is going to try and increase the number of moles. So the backward reaction is going to take place. That means the position shifts to the left. The temperature is increased. What is the effect on the position of the equilibrium? Again, if you increase the temperature, because the forward reaction is exothermic, meaning that it gives out heat. If you provide it with heat, it will try and reduce the heat. So the backward reaction is the endothermic reaction, because it's trying to reduce the heat. So backward is endothermic. Next part, a catalyst is used in the reaction. Suggest what effect the catalyst has on the position of the equilibrium. Give one reason for your answer. Now, the catalyst doesn't actually have any effect on the position of the equilibrium. All it does is actually lowers the activation energy and increase the rate of reaction. So the position of the equilibrium itself doesn't change, but how fast you get to that point actually may change. So the equilibrium position does not change. A catalyst increases the rate of the forward and reverse reaction equally. Next part. A scientist measured how the number of moles of sulfur dioxide, oxygen, and sulfur trioxide varied with time during the reaction. So, according to the graph, so you can see the time in seconds is for 300 seconds, and this is your reactants, which is SO2, and that's the reactant, right? Remember, this is num 10 and this is 5, so the ratio was 2 to 2 moles of sulfur dioxide reacting with 1 mole of oxygen. That makes sense. And when it does react, it forms sulfur dioxide, which is this line. This is the product line, right? And when it comes to this point, the concentration of the product actually remains the same. And in the graph, you can see all three of them at this point, all the way. What time is that? So we've got 50 divided by 10. Each of those boxes is 5. So that's about 210 seconds. At about 210 seconds, the concentration of the sulfur dioxide and oxygen and sulfur trioxide are remaining the same, which means the forward and the backward reactions are exactly the same. So the concentrations are not changing. That means this is where it's actually the time at which equilibrium is reached. And that's going to be useful probably for the next question. Yeah. Determine the time taken for the reaction to reach equilibrium. As we discussed above, it was 210 seconds. The explanation is because the lines become level or horizontal because rates of the forward and backward or reverse reaction are equal, or you could say because the number of moles for all three gases remains constant. 5.7. Figure 6 shows the results for sulfur trioxide. So they've just got the line for sulfur trioxide here. The question is, determine the rate of reaction at 60 seconds. Now at 60 seconds is here 2 boxes away from the 50 point. Now this is a 4-mark question. You can't simply find the number of moles and divide it by the time to get the rate of reaction. That's what the 4 marks is for. For this reaction question, you would need to find the tangent here. So how do you find the tangent? At the spot you draw a straight line. Let's see if I can draw a straight line there. Maybe redraw that. There we go. And if I extend that, so that's about 125, 130, 35. Let's say that's 135, 35, 40, 50. Let's say that's 135. And here it's 1 to 8. So the delta y is 7. The change in x is 135. So using those values, the gradient of tangent equals, the y value was 7 moles divided by, we double check that again. Yes, that is 7 divided by 135 seconds. So let's bring in the calculator for this. So 7 divided by 135 gives me 0.0518. 0.0518, round it off to 0.052 moles per second. 0.052 moles per second. Now, just for clarification, I'm going to show you what the marking scheme says. Tangent drawn at 60 seconds, correct values of y step and x step from the tangent, rate equals value for y step over x step, correct calculation of rate. So they're not actually giving a number, they're expecting you to work out. So depending on how you drew the tangent, the answer might change. As long as you got that correct, you're going to get the 4 marks. That's the end of question number 5, and I will see you in question number 6.